Are we alone in the universe? It's a question that has fueled endless curiosity, countless theories, and an unrelenting search for planets beyond our solar system. In 2016, astronomers made a discovery that brought this search closer to home: an exoplanet orbiting the nearest star to our Sun, Proxima Centauri, just over 4 light-years away. This planet, known as Proxima Centauri b, immediately became one of the most intriguing places in the cosmos. Could it be habitable? Could there be life? Or is it just another lifeless rock drifting in the vastness of space? Proxima Centauri b is the closest known exoplanet to Earth, making it a prime candidate for study. Unlike many distant worlds that require powerful telescopes to even detect, this one is right next door in galactic terms. Since its discovery, scientists have been racing to understand its characteristics, its size, orbit, atmosphere, and potential for hosting life. It orbits within its star's habitable zone, the region where liquid water might exist, which raises exciting possibilities. But its reality is far from simple. In this journey, we'll break down what we know about Proxima Centauri b, its discovery, its harsh yet intriguing environment, and whether it could sustain life as we know it. We'll also explore the challenges any life would face there, and how future missions might unlock its secrets. Could this planet be a second Earth? Or is it a place where life would struggle to survive? Let's find out. The Alpha Centauri system isn't just one star. It's a fascinating trio. At its heart are 2 sun-like stars, Alpha Centauri A and Alpha Centauri b, locked in a slow gravitational dance around each other. Then there's Proxima Centauri, a small but powerful red dwarf orbiting the pair at an immense distance. This makes Alpha Centauri a triple star system, with Proxima Centauri being the closest of the 3 to us. And it's around this dim, flickering red dwarf that Proxima Centauri b orbits, raising the tantalizing question: could life exist so close, yet so far? The journey to understanding the Alpha Centauri star system has been centuries in the making. The first recorded mention of this bright stellar neighbor dates back to the 2nd century, when the Greek astronomer Ptolemy catalogued it among the stars of the southern sky. But it wasn't until 1689 that Jean Richaud, a French astronomer observing a passing comet, realized Alpha Centauri was actually 2 stars, not 1. The discovery of this binary system was a turning point, marking one of the earliest known cases of a double star in astronomy. The story didn't end there. In 1915, Scottish astronomer Robert Innes noticed a faint, separate star near Alpha Centauri and determined it was even closer to Earth than the other 2. This was Proxima Centauri, the dim 3rd member of the system and the closest star to our Sun. At just over 4 light-years away, it became the nearest known stellar neighbor. And a century later, it would reveal something even more astonishing: an exoplanet orbiting within its habitable zone. Proxima Centauri b is a planet that at first glance seems eerily familiar. It's slightly larger than Earth, with a mass about 1.3 times that of our home planet. This means its gravity would be just a bit stronger, making it a place where humans could potentially stand without being crushed or floating away. But beyond its size, things start to look very different from Earth. Unlike our comfortable 365-day orbit around the Sun, Proxima Centauri b races around its star in just 11.2 Earth days. That's because it sits incredibly close to Proxima Centauri only, about 5% of the distance between Earth and the Sun. If our planet were that close to our Sun, it would be a scorched wasteland. But Proxima Centauri is a much smaller, cooler red dwarf, meaning its habitable zone is packed in tightly, allowing a planet so close to potentially have temperatures where liquid water could exist. Finding this planet was no easy task. Unlike large, bright exoplanets that can sometimes be seen crossing in front of their stars, Proxima Centauri b was detected using the radial velocity method. Scientists at the European Southern Observatory used an instrument called HARPS, a high-precision spectrograph, to measure tiny wobbles in Proxima Centauri's motion. These wobbles were caused by the gravitational tug of an unseen planet Proxima Centauri b, confirming its existence. With its size, location, and orbit, a big question remains. Is this world actually habitable? It sits in the so-called Goldilocks zone, where conditions might allow for liquid water, but there are many other factors at play. Could it have an atmosphere? What about the powerful radiation from its active star? These are the challenges that could determine whether Proxima Centauri b is a promising world or a harsh, lifeless rock. The idea of a habitable zone is simple, but crucial when searching for planets that could support life. It refers to the region around a star where temperatures might allow liquid water to exist, neither too hot, where water would boil away, nor too cold, where it would freeze solid. Since all known life depends on water, this zone is often the first place scientists look when assessing a planet's potential for habitability. Proxima Centauri b happens to sit right in this zone around its parent star. Because Proxima Centauri is a much cooler and dimmer star than our Sun, its habitable zone is packed in close. If Proxima Centauri b were orbiting a star like ours at its current distance, it would be a scorching inferno. But around a red dwarf, this same distance places it in the range where surface temperatures could, in theory, allow for liquid water, one of the key ingredients for life. However, just because a planet is in the habitable zone doesn't mean it's actually habitable. There's a lot more to the equation. A planet needs the right atmosphere to trap heat and maintain stable temperatures. It needs protection from harmful radiation. It needs a way to sustain liquid water over long periods. Without these, a planet in the habitable zone could still be completely uninhabitable. So, while Proxima Centauri b is in the right place, whether it's truly a place where life could exist is an entirely different question. For life as we know it to exist, certain conditions need to be met. One of the most important is the presence of liquid water. Proxima Centauri b sits in its star's habitable zone, meaning it could have the right temperatures for water to exist on its surface. But that's just an educated guess. Scientists haven't yet confirmed whether this planet has any water at all. If it does, it might be locked beneath an icy shell, trapped underground, or spread across a vast ocean, assuming a planet has the right conditions to hold on to it. Another crucial factor is the atmosphere. Without one, any water that might exist on Proxima Centauri b wouldn't stay liquid for long. An atmosphere helps regulate temperature, keeping a planet from turning into an icy wasteland or a scorching desert. It also acts as a shield, protecting the surface from harmful radiation. So far, there is no clear evidence that Proxima Centauri b has an atmosphere at all. If it does, it could be thick enough to support life, or so thin that it offers no protection whatsoever. Temperature estimates depend entirely on whether or not an atmosphere is present. If Proxima Centauri b has one, it might distribute heat and create a more stable climate. But without an atmosphere, temperatures would likely drop to around -45 degrees Celsius, making survival incredibly difficult. Still, some forms of life on Earth thrive in extreme cold, so the possibility of life can't be ruled out just based on temperature alone. One factor working in Proxima Centauri b's favor is its energy source. Red dwarf stars like Proxima Centauri burn at lower temperatures than our Sun, but they also last much longer, potentially trillions of years. This means any planet orbiting a red dwarf, if habitable, could have an incredibly long window of time for life to emerge and evolve. But while the star's longevity is an advantage, it also presents some serious challenges. Proxima Centauri is known for powerful flares, which could make life on its planet far more difficult than it seems at first glance. Unlike our relatively stable Sun, Proxima Centauri produces frequent outbursts of X-rays and charged particles, posing a serious threat to any atmosphere or water that might exist on Proxima Centauri b. In fact, Proxima Centauri b is bombarded with far more X-ray radiation than Earth, over 400 times more on average. This constant exposure makes it difficult for an atmosphere to survive. Strong stellar winds and flares could gradually strip away the planet's protective layers, leaving it vulnerable to the vacuum of space. If that happens, surface water would either freeze solid or evaporate into space, making life nearly impossible. Of the most dramatic examples of this occurred in 2017, when Proxima Centauri erupted in a flare so powerful that radiation levels around the planet spiked by a factor of 10,000 in just 10 seconds. If Earth were hit with something like that, it could fry satellites and disrupt communications. For a planet like Proxima Centauri b, repeated flares of this magnitude could be devastating, potentially eroding its atmosphere over time. However, Proxima Centauri b does have one factor in its favor: its size. Being slightly more massive than Earth, it has a stronger gravitational pull, which could help it hold on to its atmosphere and any water it might have. Whether this is enough to counteract the destructive effects of Proxima Centauri's flares remains uncertain. But it raises the possibility that life could exist underground or in shielded pockets, safe from the relentless radiation above.